Okay, so we've got 10 counters and they're placed in a box. 7 of them are red and 3 of them are green. We're going to choose a counter, put it back, and then choose again. With this information, we need to now construct a tree diagram. Again, I think it's going to be a lot easier to do a probability tree diagram, because that way we don't have to do the 7 different options and then the other 3 different options. So let's just go the 2 ones. They could be here. And I might even color code this one. I might go that that's red and that's green. How good does that look? Then we've got the 2 other options again. Red, red, green, green. Now let's talk about our original choice, right? So we had 10 counters and 7 of them were red. That means this probability is 7 out of 10. Then for my next one, the probability is going to be 3 out of 10. Now let's go for my second choice. First off, what I have to consider is if this experiment being conducted with or without replacement. Since we put the counter back, it's with replacement. So that's going to be 7 out of 10. And that's going to be 3 out of 10. It doesn't matter what we choose because we put our counter back. That makes finding these probabilities fairly simple. So we've got red, 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 red. We've got red, green, and green, green. So that's going to be 49 out of 100. That's going to be 21 out of 100, 21 out of 100, and 9 out of 100. So that was fairly straightforward. The important part for that question was to figure out that it was with replacement, so those are going to be the same probability. Are the 2 events in your tree diagram independent? Justify your answer. Yes. Successive events conducted with replacement are always, and I'll underline that, always independent. So what I mean by that is when we have 2 events that are straight after each other, when we have a counter, then we pick another counter straight away. When they're being conducted with replacement, they're always going to have the same probability between the 2. We see here that it's 7 out of 10 with that red the first time, and it's also 7 out of 10 again. The probability of R, given R already, that's already 7 out of 10. Since they're equal to each other, they're independent. It doesn't matter what you do first. If you put it back in, you're going to have the same amount of options at the end. So therefore, they're independent.